Good morning, everyone. It's a real pleasure to be back here at the Industrie 4.0 session. We had this discussion last year, and it's fascinating to see how the industry has evolved in just 1 year. I had the opportunity to be here on Thursday, and we were walking around the halls and seeing a number of interesting innovations coming to life. Today at this session, we are going to talk about how the innovations around Industry 4.0, the new class of digital twins that are coming not just from a POC or from a pilot standpoint, but how manufacturers are using that to drive their business in real life, in production. So as part of the session today, I'll start off with three different topics. So I'll start off with giving you an overview of how we see technology evolving, particularly around the digital twin and the new classes of digital twin that is important for manufacturing. And then I'll share a few examples of manufacturers who are using these technologies to drive innovation and business results. And then finally, I'll close it out with the underlying technology capabilities that is powering all this innovation. So that's the flow we have for today. I'll have a few of the manufacturers and our guests joining me on stage. And so we'll have an interactive discussion during that time as well. So to start off with, we are entering a phase, and many of you here are already starting to see this term called digital twin. And at a very basic level, it is nothing but a digital representation of a physical object. And frankly, the industry has been working on this for the last 20, 30 years. In fact, there's been work that's been going on with NASA. In the 2003 timeframe, University of Michigan actually put together an information mirroring model. And there's a lot of good work that happened in terms of how do you take a physical object and start creating digital models around that. Now, this technology has further evolved. And if you go back into the next generation of this, there's a lot of deep, rich visualization around the digital model, particularly from a CAD perspective, from a process simulation perspective. And there's been a lot of good work happening from an R&D, engineering, PLM simulation standpoint, and good innovations going on from that R&D and engineering business function standpoint. And then over the last 3 years or 4 years, we started seeing the next generation of digital twin where the digital and the physical are now connected with IoT services, with the intelligence that comes from artificial intelligence, machine learning, and the new generation of digital twin models can start communicating and start sharing information real time in terms of what's happening with the physical object. And now we are in the dawn. So one thing you want to notice is the time it took to move from one generation to the other. In some cases, it took 15, 20 years, then 5, 10 years, 2, 3 years. And we have just had past 1 year, and we are already into the next generation. And this is a generation where you're starting to see mixed reality. You're starting to see cognitive services and artificial intelligence all coming to play in creating the new generation of digital models, digital twins. Now, these digital twins not only represent the physical object, but it's going to allow humans to collaborate and interact with machines through the cognitive services. It is also going to create very rich interfaces and interactions with mixed reality. And it's taking the whole digital twin notion in manufacturing to a whole new level. And what is fascinating is this innovation was driven by people in the room, people at this event, and manufacturing has been driving the leading edge around adopting these new technologies. And what I'll share with you today is how different manufacturers are using these new concepts around Industry 4.0, digital twins, the industrial internet, from different line of business scenarios. So I'll start off with services and how people are driving transformation in the services business. Then I'll get into the manufacturing operations side from a plant floor standpoint. And then we'll finish off with how this is coming to life in the R&D and design side. So that's kind of the flow for the day. So the first example I'd like to share with you is the innovation that ThyssenKrupp elevator has been driving. And we had this conversation here last year. In fact, it was around last year's time frame when ThyssenKrupp started leveraging a lot of the advanced capabilities around IoT with predictive maintenance services to transform how they service their elevators. And they saw a huge improvement in their service operations using capabilities like artificial intelligence, machine learning. And this year, it is fascinating to see ThyssenKrupp Elevator taking the work they have done to the next level by bringing in mixed reality capabilities to completely change how their technicians are trained and how they can drive these complex tasks on site from the virtual way, and also get remote support from experts who are in the corporate office. So I'm going to run a video that will walk you through the innovation that ThyssenKrupp Elevator is doing. And it's a great example of the new digital twin in action across machine learning, artificial intelligence, and mixed reality with HoloLens. Well, in this example, just to set the context, this is an example of a technician going to do a maintenance operation. And even before the technician goes to the site, he is able to visualize the elevator and the components that he has to go and repair. And sitting in his office, he knows, OK, here are the steps that I need to do. If he has any questions, he can get help from the experts. And now he is going into the site, and that's the video that you're going to see. And once he's on the site, he starts interacting with the machine in a virtual way.
Gets information on his virtual desktop about the task orders he has to carry out.
The latest safety alerts for that elevator.
He pulls on a 3D replication of that part, pulls it out in an exploded view, and can actually see which part is making the problem.
A major advantage of the HoloLens, of course, is that we are hands-free, and we never had that experience and the capability before.
In the past, the technician needed both of his hands to operate the laptop, and now he just has his HoloLens on.
One of the most important capabilities we see with HoloLens is that we can trigger a remote call to a subject matter expert.
Call Heather.
Hey Jeff, how you doing?
I'm replacing a door board out here, but I kind of want you to check a couple things out.
Okay, let me take a look. Your JP3 is in the right position, and your motor leads are disconnected, so you're good to go.
It takes a lot of stress out, it saves a lot of time, and our field tests have shown that there's a huge potential to increase productivity with that. A job which normally takes 1 to 2 hours and maybe ends up with having the expert traveling to the site, we were able to carry it out on the first time in less than 20 minutes.
So the innovation here, what you saw was the interaction with the components, the support through the virtual and the physical interaction. And one of the most important things was the interaction with the remote agent, because the expert can now remotely see what's happening and start providing guidance. And in terms of service operations, the savings they are seeing is a work that took 1 hour to 2 hours is now taking less than 20 minutes. Right? Instead of an expert going with the technician to solve the problem, the expert can be in remote locations and support the tech. So this drives a very significant form of transformation if you're thinking about running a services business across the world, having to deal with thousands of customers across the world. So that's an example from a digital twin in action on the services side of manufacturing. Now I will change gears into operations. So in the manufacturing operation space, we, within the manufacturing industry, has been the consumer and user of data. In fact, manufacturing as a sector is the #1 sector by a big margin of usage of data. And now with artificial intelligence and these new capabilities around cognitive services, you're able to use the data, get insights, and drive real-time in-process actions. So the example I'm going to share here is from Sandvik Coromant, where Sandvik has been working with us and bringing in real-time insights using their sensors and the tools to drive in-process efficiencies across the value chain. And I'm going to run a video that talks about the success that they're having. And after that, I'll invite on stage our colleagues from Sandvik Coromant, as well as DMG Mori. And they're going to come and they're going to share with us more details of what they've been able to accomplish with these advanced capabilities.
Sanjay Ravi has been in the forefront in the metal cutting industry for more than 70 years. What we can offer for our customers is specific knowledge at the tooling level, minimizing idle time up to 50%. At Sanjay Ravi, we use Azure IoT Suite to collect data in real time and getting facts out of the machining process. With our sensor-equipped tools, that is possible. If you know the temperature, if you know the load, if you know the vibration, if you have that and can use that type of data, you can increase the efficiency of the machining process and generating savings for our customers of millions of dollars. Our decades of knowledge and experience from the metal cutting industry, combined with Cortana intelligence, I think makes the perfect blend. It is about using the cloud, giving instant recommendations about cutting parameters, speeds and feeds, connect that to our CRM system, bring that into our call centers and instantly give feedback to the customer. This enables customers to predict when to change a tool, when to order a tool, how to move out of a vibration zone. In simple words, how to become more efficient.
And they're talking about millions of dollars in savings for their customers and reducing idle time by more than 50%. So with that, I'd like to invite on stage our colleagues from Sanjay Ravi and DMG Mori, Mats, Nevzat, and Martin. Please come over. Thank you so much for joining us today. It's an amazing story in terms of the innovation that you all have been able to drive. And so what I would like to do is maybe ask a question to each of you in terms of your perspectives of driving this innovation. And I'll start with you, Mats. If you could share from a Sanjay Ravi perspective, what is the business impact that drove you to go after these type of new technologies and the innovation that you're doing in the space?
Thank you for inviting us here. We launched our concept last year at AMB and IMTS. It's called Coro Plus. This is a concept that we have been working with for many, many years in our own R&D facilities back in Sweden. So we have put sensorized tools and we have collected information from the machines in real time for many, many years. And now we are launching that towards our customers. And at the EMO this year, you will see more physical tools with sensors. Also, our partnership with DMG, where we really see that now we can get, as you say in Germany, the Fingerspitzengefühl from what is actually happening in the cutting zone in real time.
Thank you so much, Mats. Behind all this work, there's a lot of technology risks that are involved, the effort that is needed, the time frame. Nevzat, could you share your experience in terms of lighting these up from a technology perspective?
Thank you, Sanjay, for inviting us that. My name is Nevzat Herta, and I'm responsible for the IoT part of that particular project, as Mats called the Coro Plus. And if you do your homework, as we've done as last 3-4 years in working with the R&D department about the machine intelligence and the tool intelligence and some kind of domain knowledge, bring the data together, streaming data from machine and the tool and using the advanced analytics based on your excellence domain knowledge is a couple of months' job. Honestly, we was a little bit surprised at how easy and we can create it. But we know that the key for the success is that if you do the homework first, then easily you can manage the data and create this information available for that. Today, what we are doing is the second stage of that. We have adding more data because we're doing the machine learning. We need much more data from the different machine, the different setups, the different use cases. We're collecting data, creating the new machine learning algorithms, and we're focusing very much about the closed machine, also device intelligence, a device gateway, to capture the data, stream the data, as close the machine as possible, and making the necessary analytics to close the machine, and making the cold data analytics on the cloud side. There we are today.
Thank you so much, Nevzat. And it's really exciting to see you partnering closely with DMG Mori around this. And so, Martin, if you could share your perspective in terms of using the machines and the tools, and how you see this partnership evolving from a DMG Mori perspective.
Pleasure to do so, and thanks for the invitation. So, DMG Mori is world leader in machine tools. We are selling roughly around 10,000 machines to our customers, and we are world market leader. But we identified that it's not only about us digitizing the world, we have to do this together with partners. That's the reason why we have a strategic partnership with Sandvik to say every machine tool needs a tool. So you have the tool, and we put intelligence into your tool. We put intelligence into our machines, and then we have to do something intelligent out of the data, whether that is based on artificial intelligence or deep learning or simple conditional monitoring. And that's the reason why we also apply common IT technology for this with partnerships like together with Microsoft. So what we have learned is that in order to digitize our customers, we have to bring all parties together in order to make sure that the customer doesn't have to buy from all different sources for any kind of silo solution. We have to pre-integrate this, and this is our responsibility for partnering, and that's the reason why I'm very, very pleased to be on stage together with Sandvik and Microsoft. Thank you.
Thank you so much, Martin. Really appreciate the work that the group is doing, and it's amazing to see when multiple partners come together, what we can collectively accomplish. So thank you very much for your time. They will all be at the Microsoft booth, so if you want to see this and actually see this in action, we have the machinery sitting there, the tool cutting sitting there. We welcome all of you to come and have a conversation with Matt, Navseth, and Martin. Thank you so much. Thank you. Thank you so much. Thank you. So far, we covered two areas around services and from an manufacturing operations standpoint. And now I want to change gears and get into the world of design and R&D and engineering. And there are some really cool things going on in the world of R&D and design with mixed reality capabilities. And I want to share with you the work that Volkswagen is doing in this space. They've been using these capabilities to drive the next generation of design, right from the level of conceiving a design, putting that into the market, getting feedback. And I have our colleagues from Volkswagen who will be joining us on stage, Oliver Schnaffel. Before he comes on stage, I want to run a video that gives you a view of what Volkswagen is doing with mixed reality and the digital twin from a design and R&D perspective.
In this first scenario, we want to show how a designer or stylist can still draw in 2D on a monitor and then drag that 2D drawing directly onto a clay model. This allows them to skip the current step of having to print it, cut it, and then glue it onto the model. This idea is focused on two engineers reviewing an engine build plan. They see that there are two parts colliding with each other and go in for a closer look. After deciding what to do, an engineer leaves a voice note so it can be fixed before final assembly. The shape of a car greatly influences aerodynamics. This can create a gap between engineering and styling teams. Loading pre-baked simulations directly on top of physical prototypes is a great way to expose design challenges. Also, being able to drag and drop holographic models onto a remote collaborator is an efficient way to transfer content. The last scenario shows a unique use case for HoloLens at Volkswagen. After receiving the latest car design, a stylist is able to apply a new visual treatment. Then, using HoloLens, they can place the car on the street outside for quick iteration. This provides a better understanding of how their creation will look in the real world.
So it's interesting to see the digital twin from a HoloLens perspective working on behind the scenes. The data integration does bring advanced machine learning capabilities together. So it's not just about HoloLens. As you go through these various scenarios, what you see is a combination of predictive models, IoT services, cognitive services, all working together in creating the rich experiences that are required with the new class of digital twins. So with that, I would like to invite on stage Oliver Schnabel to share his perspectives on the work that Volkswagen is doing. So, Oliver, yeah, thank you for joining us today. And it's a real cool video to see how you're putting these new classes of digital twin to work from a design and engineering perspective. It's particularly personal for me because I used to be a design engineer many years back in the automotive industry, and I can relate to some of the challenges you run into when you have to change designs and how you interact with the physical world with the new designs that you need to conceive. So we'd love to get your perspective from Volkswagen in terms of why you went about with this particular concept and what was the primary business drivers behind this.
Yeah, so one case is, of course, to reduce the physical models, to save money and time. For example, in the styling process, it's very craftsmanship, so it's very hand and physical process. And we want to bring these colleagues more into the data side, because currently their master process is like the physical world, and we want to bridge like the data and the physical world. This was the main idea behind using this mixed reality case, augmented reality. But of course, the business driver is one to save the money for the physical mock-ups, which is a lot in car development. But the other interesting idea, the interesting benefit now is that we can change the way how they collaborate and how they interact with the data. Because previously it was more experts on a 2D screen in a very abstract way interacting with the data, and now they can just use their head and walk around the car and see all the details in like the car is standing in front of them, and that's why we use this technology.
Excellent. You know, could you share with us, Oluwa, how much time did it take to do this this effort? Is it multiple years for you to conceive and put this plan together? What is your experience in terms of the time frame it took for you to test drive these solutions?
Yeah, so we got the the HoloLens, the first in April last year, and we had the first use case in production in November.
Oh.
I mean, we had a lot of experience, like a lot of years in this 3D space, in traditional VR headsets and so on. But it was very efficient to get from this point to getting the device to reduce real mock-ups with this. For example, for a head-up display, we already use this tool to sit in a car and see the later head-up display layout without building any prototypes.
Okay. I'm assuming you have a lot of demand at Volkswagen because all your engineers probably want to use HoloLens and they're after you. Is that right?
Yes, of course, they are very interested. Of course, more like the young people in the styling department, they want to use it. They come over to our department and they really like it. But also the others see the benefit, what we can do with this.
Excellent. Thank you so much. And you know, we will have the actual HoloLens on the Microsoft booth, and Oliver and team will be there. So if you want to come and experience it yourself and interact with the physical and the digital world, we welcome you to join us there. Thank you so much, Oliver. It's one of the coolest examples I've seen. Thank you. And so now we will move into, you saw the new class of digital twin in action from a services standpoint, from an operations standpoint, and now from an R&D and design standpoint. And the question I'm sure in your mind is, what is needed to make all this work, and what's the technology platform behind it? So what I'm going to share with you in 30 seconds to 40 seconds is a whole architectural background. It's by no means a deep dive into the architecture, but kind of share with you the key components that are needed. So we are all in manufacturing, right? And in the manufacturing industry, you have to deal with assets, sensors that have been there for 20 years, 25 years. So any of these new technologies have to interoperate with what you have in your plant floor. So that starts with there, getting data in a secure way onto the cloud so you can use the hyperscale of the cloud to drive the advanced analytics that is needed. So Microsoft has a partnership going on with the ecosystems. OPC is a key partner for us. And there is a lot of very exciting work happening with OPC in terms of getting data from OPC UA devices in a secure way into the cloud. From there, you move into the new world of advanced analytics. And this is advanced analytics that is real time, using machine learning, stream insights, processing huge amounts of data to get the insights that you need to make decisions. And then you get into integrating all these new insights into the business processes you have. Some of them could be business processes that are already there, your ERP systems, your PLM systems. Some of them could be new business processes that are being created by the new IoT services around connected field services, predictive maintenance. So there are new SaaS offerings that are supporting these new solutions. And then finally, all this intelligence is great. The Internet of People is the most important piece, because you have to bring the insights to the people and get them to make the right decisions, make the right interactions. And this is where HoloLens, the cognitive services, all come to play. So there's an end-to-end experience delivery of the overall innovation here. So that's a quick view of the architecture that is needed to bring a lot of these innovations to life. It might look very complex. You already heard from many of our partners here that this can be done in months versus years in the past. So while there are multiple pieces behind the architecture, these implementations move very fast. And this is what is exciting for us, partnering here and seeing these innovations come to life at HANNOVER MESSE. So I wanted to share with you new innovations that Microsoft is bringing and announcing at HANNOVER MESSE. It starts off with the connected factory, the Azure suite. So last year, I was here and I shared with you the innovation we did with OPC. We brought an OPC UA connector, so you can get information from the devices into the cloud in a secure way. And this has now expanded into a full suite Azure Connected Factory solution, where not only can you connect to the devices in a secure way, you can get insights, and you can understand how the devices are performing. You can look and browse for the devices, and you can actually interact with those devices as well. And this is one of the announcements we have made. Over the course of the last 1 year, we've actually contributed a lot of open source software into this initiative. In fact, Microsoft is one of the largest contributors to open source software as part of the OPC effort. And it's all important because this success can happen only with an ecosystem of partners. It requires the interoperability. It requires all of us to work together and light up these innovations. In addition to that, there are a number of other innovations that we are bringing into the market. We are announcing these at HANNOVER. Security, cybersecurity is a core focus. Connectivity is great. The biggest risk we have around these things is cybersecurity. So we are adopting a number of standards around cybersecurity and also partnerships with different players in the security space. There's additional insights and capabilities we are bringing in with the Azure IoT Central, which is a pre-configured solution with which you can use IoT implementations. You can run IoT implementations in a much more rapid manner. We're also bringing in analytics at the edge, because a lot of the advanced capabilities are in the cloud, but for certain use cases, you need the advanced analytics right on-premise, right at the edge devices. So that's another innovation that we are sharing this week at HANNOVER. So I want to summarize the discussion with giving you an overview of what you will see at the Microsoft booth. So we welcome you to Hall 7, Booth C. There are a number of innovations. You already heard what we are doing with ThyssenKrupp, with Sandvik Coromant and DMG and Volkswagen. We have a number of other innovations out there, a number of partner solutions with Rockwell, with Siemens, with Icertis. Icertis does some great work around blockchain in manufacturing, aligned with contract management. And those are all new innovative business processes that are coming with IoT services. So we welcome you to come and experience these for yourself, and also get an opportunity to work with the partners to see how you can light up these scenarios in your own businesses. So with that, I will conclude the speech, and thank you for your attention, and look forward to seeing you at our booth, and have a great HANNOVER MESSE conference. Thank you.